The EPA's multifamily high-rise program offers eligible buildings 2 paths to earning the Energy Star. Both paths are required to follow the testing and verification protocols. This document can be found on the website, and we suggest having a hard copy available during this presentation. Part 1 of this webinar provided you with an overview of this document. Part 2 and Part 3 provide greater detail on each of the actual protocols. The testing and verification protocols are intended to help the responsible parties ensure that requirements are properly written into construction documents prior to construction, and to help the verifier confirm in the field what was specified by the design team. If the project is pursuing the performance path, the inspector should confirm that all installed components and equipment meet prerequisites and match what was modeled. If the project is pursuing the prescriptive path, the inspector should confirm that everything complies with the prescriptive path's requirements. As mentioned in Part 1 of this series, the T&V protocols cover all building components, including appliances, HVAC and hot water systems, building envelope, and lighting. This webinar will address major elements of T&V protocols 1 through 5, which cover appliances, domestic hot water systems, envelope, garages, and heating and cooling. The remaining protocols are covered in the Part 3 webinar. Each protocol is not covered in detail in these webinars, and the responsible party should be familiar with the full document prior to construction. If you have a copy of the T&V protocols, please turn to page 14. The multifamily high-rise program requires that all installed appliances, including refrigerators, dishwashers, clothes washers, and vending machines, be Energy Star labeled. During the plan review phase, construction documents should clearly specify this requirement, or specify actual model numbers that are Energy Star qualified and have been verified using the Energy Star website. During the as-built inspection, the inspector should write down and take photos of the model numbers of all installed appliances. The inspector may use sampling to document compliance with this requirement. If there are different model numbers of a specific appliance installed in a single building, for example, a smaller refrigerator installed in studio apartments and a full-size refrigerator installed in larger apartments, be sure to note which units have which model and properly adjust your sampling. If possible, take a picture of the Energy Star logo in addition to the model number. A statement of substantial completion, or SSC, is acceptable for this protocol. Have whoever is preparing the SSC, the architect, the GC, the subcontractor, provide you with photographs, delivery tickets, or invoices for the installed Energy Star appliances. Copies of approved submittals are not sufficient. You need proof of what was actually installed. DHW testing and verification requirements are described on pages 16 through 20 of the protocols. Requirements related to heating and cooling are described on pages 40 through 60. The heating, cooling, and domestic water heating protocols cover all types of testing and verification, from visual inspections to third-party commissioning. During plan reviews prior to construction, the equipment schedules, distribution systems, and their controls should be examined in detail to ensure that they are in compliance with program requirements prior to construction. During the site inspections, the main goal should be to verify that the system will perform according to the assumptions in the proposed design. 100% of central systems will be verified on site, such as boilers and storage tanks, but ResNet sampling procedures can be used for verifying distributed systems, plumbing fixtures, and delivery temperatures. The majority of the HVAC protocols have the same basic schedule for testing and verification in the field, as well as responsibilities during the design phase. The figure on the right shows a sample project schedule using a Gantt chart format. Commissioning of the system occurs at 2 points. First, during pre-construction, with plan review and feedback to the design team, and second, on an ongoing basis during construction. Inspection, testing, and final commissioning are conducted during the turnover or acceptance phase of the installation of the system. Training should occur following installation of the system and completion of all quality assurance and verification procedures. The developer or contractor should ensure that deliveries are inspected prior to accepting them in order to verify that any product substitutions made by the distributor or manufacturer have not resulted in equipment being less efficient than that required by the proposed design or prescriptive path. A minimum of 1 on-site inspection is required for these items, preferably immediately after installation, so that corrective action can be taken if necessary. Delivery tickets may be used to verify complete shipments, but on-site inspection of a sample of installed equipment is required. Prior to construction, one of the first things you should verify is that the size, type, design, controls, and rated efficiency of the heating, cooling, and hot water systems meet the proposed requirements for the path selected and match the proposed design. During construction, the inspector must verify the system will perform according to the assumptions in the proposed design model or meets or exceeds the requirements listed in the prescriptive path. For the HVAC and hot water protocols, the developer should hire a commissioning agent or energy consultant who will perform the quality assurance and verification requirements that cannot be completed by the licensed professional. Verification will occur in the field in addition to submittal reviews of manufacturer's cut sheets or invoices detailing system manufacturer, model, size, and location. These documents should be kept with the building file. These should also be used to prove ENERGY STAR qualification and efficiency rating where applicable. The next few slides will explain what commissioning of the system is required. Whether performed by a third-party commissioning agent or another qualified verifier, the photo template and testing and verification worksheets must be used to document the commissioning results. Instructions on how to use these worksheets will be covered in a separate webinar. Statements of substantial completion can be used for these protocols, but only from a qualified third party. The prerequisite for pipe insulation should be clearly written into the construction documents prior to construction. The responsible party should visit the site as soon as the pipe insulation work begins in order to catch any deficiencies as early as possible. Take photos to document the thickness of both the insulation and the pipe. The combustion air and venting configuration must also be confirmed during the plan review process prior to construction. Then, verify on site that the configuration is in conformance with the proposed design and appropriate National Fire Protection Association (NFPA) standards. Gas systems use reference NFPA 54, the National Fuel Gas Code, and oil systems use reference NFPA 31. The responsible party should provide training for all HVAC systems for the management personnel involved and provide a summary of the training to be kept with the building file. Also, confirm that all applicable operating and specification manuals have been delivered to the building staff, that staff members have been properly trained, and that they are aware of their responsibilities to maintain and operate the systems properly. Some T&V protocols only apply to domestic water heating systems, such as verifying that the domestic hot water system is set to deliver temperatures between 120 and 125 degrees Fahrenheit. Measure these temperatures both in the apartment and at the water heater or boiler to confirm that the system is in compliance with program requirements. These temperatures should be recorded in the T&V worksheets. For central hot water systems, a self-contained or electronic mixing valve must be specified to control hot water temperatures. Mechanical valves may not be specified. Additionally, confirm that storage tanks off central systems are insulated in accordance with code. These requirements must be identified in the construction documents prior to construction and then verified and documented with photographs on site. Flow rates and water sense labeling of plumbing fixtures should be reviewed in construction documents during the design stage for compliance with program requirements. Reviewing submittals before purchasing an installation is recommended, as these items are often overlooked during construction administration. Once installed, the inspector must provide photo documentation of the flow rate rating or water sense label of a sample of inspected plumbing fixtures. If following the performance path, these rates must be used in the as-built model. If following the prescriptive path, they must meet those low flow requirements. Let's review the testing and verification protocols that apply both to central and distributed heating and cooling systems. These requirements should be explicitly written into construction documents and then confirmed during the plan review. For all forced air systems, be sure to integrate a preliminary list of duct sealing details into the construction documents to ensure that all transverse joints are sealed as described in detail on page 42 of the T&V protocols. Heating and cooling supply and return ductwork must be insulated to a minimum R6 in unconditioned spaces. Keep in mind that an R8 is required here if following the prescriptive path. If using flex duct, installation must meet the Sheet Metal Air Conditioners Contractors National Association (SMACNA) installation standards. Please refer to Appendix C of the T&V protocols. These sealing, installation, and insulation details must all be photo documented prior to sheetrock. Visit the site before sheetrock is installed. During your inspection, take plenty of photographs of all installations relating to the heating and cooling systems, ductwork, piping, venting, equipment, etc. Be sure to get clear photographs of the equipment's faceplates so you can refer to them in your documentation. For systems designed with outdoor air supplied directly to the heating or cooling system, motorized dampers must be specified that will automatically shut off when the systems or spaces served are not in use. This must be explicitly written into construction documents and then demonstrated in the field by the installing contractor. The responsible party, this may be the inspector, verifier, or third-party commissioning agent, will have to verify different data depending on the types of heating and cooling systems installed. For example, he or she may have to obtain and keep documentation on file showing correct field-measured refrigerant charge, field-measured airflow over the evaporator coil, nameplate efficiency, nameplate heat exchange capacity, consistent with the manufacturer's specifications. Enter applicable data into the T&V worksheets and confirm whether these efficiencies match the proposed design or prescriptive requirements. There are a number of verification requirements relating to central heating and cooling systems. The plan reviewer should look for these items in the project's drawings and specifications, and have the design team account for them if not already accounted for. The field inspector will then document all installed requirements in the field. Take plenty of photos, being sure to document all prerequisites and energy reduction measures. Again, be sure to take clear photos of nameplates so that all product information is legible. For centrally located hydronic heating systems and chilled water and condenser systems, all supply and return headers must be installed in a reverse return configuration. In other words, the first riser supplied would be the last returned, as seen in the image above on the left. As an alternative to piping reverse systems, the system could be sized based on a water velocity of less than 4 feet per second. The total pressure drop of terminal unit branch piping and fittings between the supply and return risers must be significantly greater than the total pressure drop from the top to the bottom of these risers. In the field, confirm with the plumber or appropriate subcontractor that he has installed piping in this way. Document the total pressure drop. Calculations and assumptions for sizing circulating pumps must meet Chapter 43 of the ASHRAE Handbook, HVAC Systems and Equipment, or equivalent industry-accepted standard. During plan review, confirm that the engineer has sized all pumps accordingly. In the field, confirm that the specified pump has been installed. These calculations should be kept with the building file. All terminal heating distribution equipment must be separated from the riser or distribution loop by a control valve or terminal distribution pump, so that heated fluid is not delivered to the apartment distribution equipment when there is no call from the apartment thermostats. Although not required, EPA recommends adding a note during the plan review phase requiring that circulator pressure controls be adjusted to ensure that, first, sufficient GPM is achieved at the terminal units furthest from the pump, and second, that at terminal units closest to the pump, differential pressure across the closed terminal unit zone valves does not exceed valve manufacturer guidelines. When inspecting central hydronic heating systems, the inspector must verify the proper specification, installation, and operation of temperature and pressure gauges, sensors, and set points. At minimum, heating controls should have the capability for outdoor reset of supply water temperature, warm weather shutdown, and night setback. In the performance path, these temperatures must be used in the as-built energy model. The design, supply, return, and delivery temperatures should be clearly recorded in the construction documents or mechanical schedule. These temperatures must then be verified after installation and startup to ensure predicted performance. For example, return water temperatures for condensing boiler systems impact system efficiency. If the temperatures don't meet the design, the rated efficiencies may not be achieved. Supplemental heating systems should not be specified for pipe freeze protection in unconditioned spaces if the building is pursuing the prescriptive path. If specified, their energy consumption must be modeled via the performance path. Keep an eye out for these during your field inspections. If installed, take photos of nameplates to be sure the accurate sizes are included in your as-built energy model if the building is pursuing the performance path. Additionally, when you're in the field, be sure to verify the following. First, that temperature gauges have been installed. Take readings. Second, that the outdoor temperature sensor has been installed in the correct location and that it's functioning properly. Third, that the supply temperature is set correctly and that the sensor is functioning properly. Fourth, the location of the hydronic heating system. Is the boiler room located on the roof or in the cellar? How is combustion air venting configured? How is boiler venting configured? Fifth, that piping is insulated correctly. And sixth, that return water temperature meets design. If following the prescriptive path, a project's cooling tower fan motor must be equipped with a VFD controlled by a temperature sensor on the condenser water supply pipe. This should be verified in construction documents prior to construction. During the site visit, the sensor reading should be verified against the installed immersion gauge reading, as well as a temperature measurement of the pipe surface. In-unit duct systems shall be designed to effectively meet the heating and cooling loads for the spaces served using the Air Conditioning Contractors Association Manuals J, D, and S, ASHRAE 2009 Handbook of Fundamentals, or a substantively equivalent procedure, and provided by the design engineer for a review prior to construction. For improved performance, the EPA recommends, but does not require, compliance with the quality assurance and verification requirements outlined in version 3 of the ENERGY STAR Qualified Homes HVAC System Quality Installation Rater and Contractor Checklists, where applicable to forced air systems. Bedrooms must be provided with any combination of transfer grills, jump ducts, dedicated return ducts, or undercut doors to provide pressure balancing. This must be verified on-site with photo documentation in a sample of apartments. As a prerequisite, total duct leakage for in-unit systems shall be less than or equal to 8 CFM25 per 100 square feet of floor area and less than or equal to 6 CFM25 per 100 square feet of conditioned floor area for units larger than 1,200 square feet. Following the procedures outlined in your duct leakage tester operation manual, a 1-point test for total duct leakage in the main duct shaft using a calibrated fan measured under depressurization or pressurization is acceptable for this measurement. When conducting a duct leakage depressurization test, the flow conditioner and one of the flow rings must always be installed. Provide a summary of results of duct leakage performance testing. A sample table is provided in the T&V worksheets. In-unit heating system requirements are similar to those for central systems. The inspector must verify the proper specification, installation, and operation of temperature and pressure gauges, sensors, and set points. At minimum, heating controls for hydronic systems should have the capability for outdoor reset of supply water temperature, warm weather shutdown, and night setback. Where air conditioning units penetrate the building envelope, verify that the opening around the unit has been properly sealed to be air and weather tight, and that an insulated cover has been provided as required by the prerequisites. It's very important that the AC sleeve is sealed to the opening in the structural wall, as well as to the exterior facade, to ensure a continuous air barrier. The next few slides will cover protocols related to the building envelope, which begin on page 24 of the T&V protocols. When reviewing plans and specifications before construction begins, confirm that the systems managing flow of rainwater, heat, and air are identified throughout the exterior enclosure and are continuous. Review wall sections and request that shop drawings be submitted to you as well. The program requires that all insulation be installed to ResNet Grade 1 standards, or Grade 2 for walls with continuous rigid insulation. Masonry buildings with metal framing must have continuous wall insulation, either in the exterior wall cavity or on the interior between the sheathing or CMU and studs. Steel and metal buildings must have continuous exterior wall insulation. The timing of this inspection may vary depending on whether the insulation is installed on the interior or exterior of the wall, or both. During the plan review, fill out the T&V worksheets describing each element of the wall assembly and its R value. For example, outline the wall as consisting of 4 inches brick, 2-inch air gap, 2-inch XPS, 8-inch CMU, 3 5/8 inch bats and steel studs, and sheetrock. The T&V worksheets must be filled out before arriving on site. You should compare the data specified in the plans and specs to see what is installed. Update the T&V worksheets in the field to reflect any changes in the built condition. The data collected during the inspection must be fed back to the design team for correction or updating to the as-built model if following the performance path. The installation inspection is a good time to verify installation of the air barrier, which should be continuous around the whole building. The air barrier requirements will be described later in the webinar. You should plan on making at least 3 trips to the site to verify all wall construction and insulation components. Take photos of the insulation installation at all intervals: before it has been installed to verify framing construction and air barrier, after it has been installed to indicate proper installation, and after drywall has been installed to verify proper sealing. If your building has insulated floor perimeter edges, take a photo of the insulation installed between the ceiling and floor levels. Each unique wall condition should be inspected and documented. Use a ruler to indicate the insulation's thickness. If possible, take a picture of the insulation's R value. Sometimes this is written on the bats or boards already. If it's not written on the insulation, try writing down the R value on a piece of paper and hold it up against the piece of insulation. For example, write R10 on a piece of paper, hold it up against the 2 inches of XPS that you're describing, and take a photo of that to remind yourself of the installed assembly. Documentation of below-grade wall installation will typically be an inspector's first visit to the site. Ensure that you'll have opportunity to review the installation before backfill of foundation walls. Take photos of the foundation wall before insulation has been installed to show application of the water, vapor, and air barrier. Then take photos of the installed condition, both with a measuring tape and from a distance to show the assembly. For projects with exterior insulation, it's important to be aware of the project schedule, as builders frequently follow exterior installed insulation with the remaining exterior finish, so the window of opportunity for inspection may be small. Take photos of the insulation at varying points, including around corners and at adjacent buildings. Confirm that there are no large gaps between insulation panels, and that panels are installed flush to the CMU or sheathing. Take photos using a measuring tape to indicate thickness. When reviewing installation of cavity insulation, the inspector should verify that the insulation is free of voids, gaps, or slippage and compressions. The insulation should be installed such that it is flush and in contact with the interior wall surface, the drywall, and should completely fill the stud cavity. For example, 3.5-inch bats should not be installed in 6-inch studs. Confirm that bats are installed properly. Splices should be used to surround wires, junction boxes, pipes, and other obstructions within the insulated cavity. To achieve the required Grade 1 installation, the installed insulation must completely fill the cavity. The insulation should be cut exactly to the size of the cavities they fill and should not be compressed. The insulation should fill each cavity completely, with no substantial gaps or voids around obstructions. Occasional and very small gaps are acceptable for Grade 1, but no sheathing should be visible through gaps in the material. If there are moderate defects, such as gaps around blockages, compression, or incomplete fill, this would be a Grade 2 installation. If your project has specified continuous insulation with sufficient R value for your climate zone, the interior cavity insulation is only required to meet Grade 2. The envelope protocols that apply to the roof begin on page 28 of the T&V protocols. The inspector should conduct a visual inspection using the T&V worksheets for installed roof insulation. Confirm that the insulation has been installed in accordance with the manufacturer's specifications and that it matches the R value and assembly specified in the drawings and specs. When inspecting framed roofs, confirm that there is no excessive use of framing materials, that roof ventilation has been installed correctly, and that there are no other factors that would compromise the final effective R value of the insulation. As with the wall insulation, take a photo of the roof insulation with a measuring tape to document its thickness. When inspecting pitched plank roofs, review the insulation software calculator results. Taper Plus is a common product used to confirm the effective R value matches that of the installed assembly. Use a measuring tape to verify thickness at drains and at the roof perimeter. Insulation should be inspected at one location per 70 feet of perimeter. Be sure to confirm at least 2 locations where roof insulation reaches its maximum thickness. Additionally, take a photo of the completed assembly. The inspector should be aware that roof insulation can be installed very quickly and that the window opportunity for inspection can be small. Be sure to keep track of the construction schedule to ensure inspection is possible. Each unique roof type should be inspected. For example, Be sure to review both main roofs and setback roofs, as they may have different assemblies. A minimum of 15% total roof area must be inspected for each roof type. Changes to the proposed roof assembly must be reported to the design team to ensure that the installed R value is used in the as-built energy model or meets the prescriptive roof insulation requirements. The envelope protocols that apply to floors begin on page 31 of the protocols. The inspector should conduct a visual inspection using the T&V worksheet for floor construction and insulation. Confirm that the insulation has been installed in accordance with the manufacturer's specifications and that it matches the R value and assembly specified in the drawings and specs. For below-grade slab floor insulation and slab-on-grade insulation, the inspector should visit the site prior to pouring of concrete. For framed floors, the inspector should verify that excessive use of framing materials, installation of crawlspace ventilation, or other details that may compromise the final effective R value of the floor assembly are properly documented for in the T&V worksheets. Take photos of the thickness of the insulation using a ruler, of any challenging locations, such as corners, and post-installation. Changes to the proposed floor assembly must be reported to the design team to ensure that the installed R value is used in the as-built energy model or to ensure that the floor meets the prescriptive path requirements. The envelope protocols that apply to windows begin on page 34 of the protocols. The program requires that all windows be double or triple pane with low emissivity glass or coatings. Plans should call out the assembly U value, not just the glazing's U value. Have the architect provide data sheets indicating the window's performance specifications, such as frame type, U value, gas fill, solar heat gain coefficient, and Energy Star label if applicable. Energy Star windows are not required, except for wood frame buildings pursuing the prescriptive path. When reviewing plans before visiting the site, take note of each different type of window, double hung, fixed, casement, etc., and fill out the T&V worksheet. You'll have to inspect at least one of each window type in the field. If you find that any installed window differs from the window specified and documented, document any discrepancies and notify the design team. Suggest that the builder construct a mock-up of the window installation before installing them in the building. The mock-up will give you an opportunity to resolve any issues with fit, operation, or effective connections to the weather and air barrier. Plan your visit for a point at which you'll be able to inspect windows at a few progress points, installed in the rough opening but unsealed, and later when installed and sealed to the rough opening. Pay attention to how the window is sealed to the rough opening and how the air barrier is kept continuous at that point. Consider using a smoke pencil to confirm sufficient air sealing. Take photos of a number of components including NFRC or Energy Star label if available, proper connections to the weather and air barrier and air sealing, and use a low-E sensor device to identify low-E coating. You might have to open the window and test from the outside in. A statement of substantial completion is acceptable for this protocol. It should be completed by the installation contractor and address everything you would have during your inspection, including performance specifications and photographs. The envelope protocols that apply to doors begin on page 36 of the protocols. Before visiting the site, confirm that weather stripping is specified in the drawings and specs for all cellar or mechanical doors, doors between corridors and stairwells, all exterior doors, doors between apartments and corridors, and doors separating unconditioned or vented spaces. Specified weather stripping should have a rigid fastener and replaceable foam gasket. This inspection can typically be combined with a final site inspection. Confirm that weather stripping is installed on all doors where required. Try using a smoke pencil to verify the tightness of the components. Confirm that vestibules have been constructed where required by local building code. Take photos of the installed door indicating weather stripping, proper fit, and connections to weather and air barriers. If applicable, take a photo of the door's NFRC rating. The protocols that apply to garages begin on page 38 of the protocols. Before construction begins, confirm on the building plans that the garage space is not heated. Radiant heating may only be used to prevent ice formation on the ground as a safety feature only. In addition to not being heated, the garage must also be completely air sealed from the conditioned building. Have the design team include a list of items to be sealed in the garage based on the plan review and the prerequisites. During your inspection, visually confirm and use the T&V worksheet to confirm that heating systems, if present, are used only for safety considerations. These should be properly controlled and locked. Confirm that the garage is fully compartmentalized. Check for weather stripping on all doors, and that pipe and conduit penetrations have been fire stopped or sealed. This inspection will typically come at the end of construction. This concludes Part 2 of the Testing and Verification Protocols webinar. You should now have a greater understanding of what is required in these protocols that apply to your review of construction documents during the design phase, as well as what's required of you to inspect on site. Please see our website for Part 3 webinar in this series. Please also refer to our website for additional information or contact us via email.